till this slide, then what is the objective or what is the classification of survey based on the objective of survey, right? Today we will start from the principle of surveying. Now, if you consider surveying, there is two basic principles, and almost in all the project, all the initial planning purposes, we ultimately use these two principles. First one is to work from whole to part. What is the meaning of working from whole to part? So, see, if this is a large plot and you have to do survey of this large plot, then what you have to do? You have to first establish your control point or control station like this. These are your control stations. Once you fixed up your control stations with higher precision, you can set up or establish your minor control points like this one with relatively less precise method. So, as you can see, in the beginning, you are almost taking the whole part, and on that whole part, you are establishing your control points, and then you are coming to your part wise, right? So that is the meaning of working from whole to part. Now, why that is done? The idea of working in this way is basically to prevent the accumulation of the errors. Suppose if you have made any errors measuring this side length or this length or this angle, then obviously for a large length you have made a small mistake. But suppose the similar kind of mistake you have made measuring this part, and from this part if you are trying to go towards the upward direction or from the part towards the whole direction, then what will happen? The accumulation of the error will be there. So larger amount of error will be there. And that's why we always try to work from whole to part. To explain it further, let us think in this way. Errors are uncontrollable. There will be some kind of error. You can't totally make it zero. You can't make totally you can't make error equals to zero, right? You can't avoid error. So obviously there will be some kind of error. But if you are first measuring this and then going to measure the larger part, then what will happen? If you are doing mistake in the smaller part, while going upward direction, there will be accumulation of the error. There will be the errors margin will be much more. The error amounts will be much more. But if you are at first you have set up the station point, and doing so, if you have made a small amount of error, that will not affect your total precision of the works, right? So that's why we will always go from whole to part. Let us take an example. Suppose you have measured a line AB. Now suppose on a perpendicular distance you have to plot a line which is having point M and point N. Suppose this is O. Now suppose from this line you can measure OM and MN. This is the first way. You are measuring OM and then you have plotted M, and then you have measured MN and you have plotted MN. You have measured these things in field and you are plotting in the pen and paper, simple paper. So suppose after measuring BA with some scale, you have drawn it to a drawing paper. Now you have measured from BA perpendicular distance OM, and then you have measured MN also. So if you plot OM in the perpendicular distance, you will get point M, and from that if you plot MN, you will get point N. But in the pen and paper, what will happen? If you have measured it correctly, if you have plotted it correctly, that is okay, but you are not able to do so every time, so there will be some kind of error. Now suppose you have plotted OM, and while plotting you have made some mistake. Suppose instead of M, you have plotted at M dashed. Now you measure Mn, so in the measuring and in the plotting there will be some kind of error. Even if you correctly measure Mn and correctly can plot Mn, still as you are plotting from M dashed, so obviously there will be a shift like N dash. Okay, so even for the smallest part of measurements, the other measurements are getting affected. So that is the problem when you are working from part to whole. This is the working from part to whole. But suppose you have done in this way. You have at first plotted AB, and then by measuring you have plotted ON. There can be some kind of obviously error can be there obviously, but that error only will be due to the measurements of ON, will not be due to the plotting of M and subsequent adding up of the error. Okay, so then here the precision will be much more. If I have to give an example, say your measured distance is 10 kilometer. In a proper scale, suppose you are doing this, you are plotting this in your map, you are in your paper, and suppose instead of 10 kilometer, you have plotted 10 kilometer, 10 meter. Some wrong measurements you have done with the help of the scale. So it is like this. Now from M to N, suppose this distance is 20 kilometer, but you have made an error of again 10 meter. So your ultimate error will be 30 kilometer, 20 meter, right? Suppose the minimum error in every measurements you can rectify or you can control up to say 10 meter. Beyond that you can't control. Then obviously, if in the beginning you are plotting ON as its measure is 30 kilometer, you can you can make a mistake and suppose that 30, instead of 30 kilometer you are plotting 30 kilometer 10 meter. So obviously the error will be minimum. The error will be only due to the measurements of the length but not due to the previous measurements. And that is the benefit of working from whole to part rather than from part to whole. Is it clear to everyone? If you are having any question, you can ask right now. যদি তোমাদের কোনো কোয়েশ্চেন থেকে থাকে জিজ্ঞাসা করতে পারো। Whole to part or part to whole? You are asking? Whole to part, na? In the suppose I have to measure a larger amount of plot, then what I will do? In the beginning, I will first mark my control point, and I will mark those points, the distance between them, all these things very accurately. So I have plotted some station point, some control point throughout the whole part, taking the whole part. Then I have to plot, suppose the traverse I am plotting, and then I have to go part wise. Then I have to go in more localized area. So at first you have to set up the control points, then you have to go towards the setting up the minor control points. Okay. After setting up these control points, you have to go in the inside. But in the part to whole, you are at first measuring the smaller part or the inside part, then you are measuring the distance, and then you are coming to the larger part for the same plot. So is it clear to everyone? Clear holo ki tomar question?
Sir,
Okay.
sir, in the slide, the point 3, the otherwise would expand to greater magnitudes. If what this line means?
What is the line you are talking about?
Yeah, in your slide, the point number 3, the otherwise would expand to greater magnitudes if the reverse
It's
was
supposed
this.
to be greater magnitude. Reverse process means part to whole. If the part to whole is followed, reverse process means part to whole. Okay.
Okay, sir.
Like I have explained here, this is whole to part, and this is part to whole. So it is very important for survey work to go from whole to part. So suppose you have to plot a you have to plot a plot. Suppose you are having a plot, or you have purchased a plot in a village, and just beside your plot you are having a plot of your friend. Okay, beside your plot you are having a plot of your friend, of another friend. So at first, in the beginning, you will plot your entire plot. Then you will, suppose you want to make what is your bedroom, what will be your bathroom, then you can plot those parts. Okay, so in the beginning you have to do the whole part. You have to set up your control points. It is it is the most common practice in surveying works, in any type of surveying works, in any type of project, whether it is personal building project, whether it is any project of national importance. In any case, this is the most common part, that you have to work from whole to part. Is it clear? Can we move to the next slide?
Yes, sir.
Okay, okay, okay. So now the second most important point in survey work, always you have to locate a point by at least two measurement. Why I am saying so? Suppose in the field I am drawing by red. Suppose in the field you are having a building like this, and from this building corner you have a tree, or suppose you are having a fence. Suppose the fence is at a distance of 100 meter. Suppose the tree is at a distance of 150 meter, right? Now suppose this is the plot, this is the field, right? You have taken the measurements. Now suppose you want to, I am drawing the drawing in a paper. Suppose in the paper you are making the same drawing. Ultimately the purpose of the survey is to make a drawing or make a plan of the same thing which you have, which you are observing in the field. So suppose the building you have plotted as per scale. Now suppose this 150 meter you will plot, and there you will mark a T tree, sorry, not T. So you will mark a tree. Now as per 150 meters, suppose this distance is this much. Now you want to plot a tree, but will it be a proper measurements? Because this, if you think about 150 meter, from this point at 150 meter distance, there could be several points, and we know that from a point, if any point maintain a certain constant distance, it will follow the locus of a circle. So obviously, if you think this as a center, and with this radius there will be several number of points. So how you can be sure that this will be the point of the tree, right? For that reason you have to measure at least two measurements. It should be there. That means either what you can do, either you are measuring this is 150 meter, you can, and you can have a similar type of measurements from the other end, and suppose this is 250 meter, then obviously it is very clear that two this is 250 meter. If you say 250 meter radius circle is one circle is possible, and here 150 meter radius circle is one circle is possible, and their intersection point will be one single and one particular point. So then you can mark your tree. So either two linear measurements can be there, like here it is explained. From PQ you want to plot R, then either you have to know the distance QR and the distance PR, then only you can plot, right? In the similar way, otherwise what you can do, you can you can draw a perpendicular from R to PQ, and you have to know the perpendicular distance. So that is also basically a point where you can draw 90-degree perpendicular, and you know this distance. So either these two also you have to know, or you have to know this QR distance along with the angle which this R is making with PQ, or QR is making with PQ. So you have to know this angular measurements as well as this linear measurement. Or you can have two angular measurements, that from Q you will measure and you will specify a direction, and from P also you will specify a direction. Then those two direction will cut out at a point and will mark this point as R. So then otherwise you have to know two angular measurements, that also possible. Here also one linear and one angular, but from both the side. So at least this kind of two measurements at least should be there. Otherwise, to locate a problem, to locate a point, there will be difficulties. There will be error uh, related to this sort of measurements. Is it clear to everyone? এটা কি clear হলো? If it is not clear, you can ask for. I can repeat.
Sir, আরেকবার তো repeat করে দাও।
Okay, okay. Suppose কেউ ইয়ে করো না, চ্যাট বক্সে মেসেজ লিখো না, কারণ বারবার আমাকে তাহলে প্রেজেন্টেশন থেকে বেরিয়ে আসতে হবে। If you have any question, you can just unmute yourself and you can ask. Okay. First point. Okay. First point. First point means about the two distance, right? You were asking about the two distance, right? Okay. Let me explain further. If you want to plot, suppose this is a building and you want to locate it, you have seen, suppose this is the building, you have seen your project impact building. Have you seen in Jadavpur University? You have attended some classes, right, in the non-pandemic period?
No, sir.
Okay.
No, sir, not a single.
Okay. Suppose this is a building and from the building corner, you know the distance of a particular point is 150 meter. But how can you plot this to a drawing, in a drawing? Because even if you have measured this 150 meter, you don't know in which direction. Because this 150 meter, what is the angle it is making? It can be in this direction also. It can be in this direction also, right? Then how can you plot this 150 meter or this feature in the ground? Suppose here it is, here one fence sort of things is there, or one tree is there, or one lamp post is there. How can you plot this lamp post to a drawing? How you will plot? You know this distance is 150 meter, but you only know one distance. How with the help of this one distance you can plot? Because you know from a point with a constant distance, there are number of points can be there. Because if you think that this is a center and this is a radius, a circle can be drawn, and on that circle every point will have similar distance, like I have shown you here. Here from this point at 150 meter there could be several points, right? But how you are sure of these points or this tree, and how you are able to plot these things in the drawing? For that reason, you at least should have another one measurement. That means at least you should have two measurements. Either you should have the distance from this end. So what you can have, from this point you are having a distance, from this point you are having a distance. Then this sort of point, suppose a point which is having 150 meter distance, suppose a point which is having 150 meter distance from this P end of the building can be several. And from this, suppose 170 meter distance can be several points. But only a single point is possible, which is having a distance of 175 meter from Q and 150 meter from P, right? Because these two circles will intersect at a single point. So obviously one single such point is possible. That's why if you measured from two different points and you are having two distance, obviously you will get a particular single point, which you are not able to get if you are having only one linear measurements. Is it clear? এটা কি বোঝা গেল?
Yes, sir.
Okay. Not only two linear measurements, also you can have one linear and one angular measurements. Because suppose PQ, with respect to that your R is 30 degree, then you have measured, then you will plot this in the drawing. Suppose you have plotted PQ as per scale, and with the help of the any angle, suppose any angle device, you can measure the angle and you can specify the direction, and on that direction you have measured suppose this distance, you will plot this distance. So obviously then this is also one type of thing you can do, that means one angular one distance measurements. By this sort of measurements also you can get a single point, okay, or you can plot the point. Is it clear, this method? Is
Yes,
this
sir.
method? Huh? Bolo?
Yes, sir. Clear.
Okay. Similarly you can do these measurements also. বলো কে কি বলছো, কিছু বললে? Okay. For these measurements, what you are doing, from both the ends you are measuring the angle. Then what is happening? Suppose this is PQ. You have measured the distance and you have plotted in the diagram. So you have plotted PQ. You know the point of a lamp post, and it is making an angle of 60 degree from this end, and it is making a 30-degree angle from this end. So what you will do? You will plot a line from here which is making a 30-degree angle. Also you will plot a line from here which is making a 60 degree. So obviously both this line will cut at a point, and obviously that point will represent this lamppost. So in this way also we can plot. So obviously by measuring to angle also it is possible. So anyhow, any point you want to locate, you have to measure at least two measurements, and these are the examples by which you can do. So I guess it is clear to everyone. Can I move to the next slide?
Yes, sir.
Okay. Now classification of surveying based on the instrument used. The very basic type of surveying is chain surveying, which almost already you have learned. Professor Ankush Mujumdar have discussed this part. So surveying is basically several type of surveying is there. Last day also we have discussed. Surveying can be classified on different type of surveying depending on the instrument used. Chain surveying is one type of surveying where the main instrument used is chain or tape, right? The second type of surveying is traverse surveying, where we will make traverse, where not here you will see only chain we are using, that means only linear measurements is there. In the traverse surveying, not only chain but along with that compass is also employed. That means not only linear measurements we are carrying but also angular measurements we are doing. So that is the that what we will do in the traverse surveying. Then we will come to this tachyometric surveying. Here we will use tachyometer, one special type of lens sort of things will be there, and this side you will place your eye, and in this side you will have some stadia like this. So when you will view, obviously it will dive, three diverging ray will be there through these three stadia, and here you will have one staff, graduated staff, some marking will be there. So if you take the mark with respect to this, and if you able to take the mark with respect to this, then you can get the difference, that is called staff intercept. If you are able to measure the staff intercept, this distance you can measure easily by following one equation, k1s plus k2, by knowing the k1 and k2, which will be constant for a particular type of lens. K1 and K2 is known as multiplying constant and additive constant. So here what you have to do, you don't have to even go for chain, or you don't have to measure the linear distance. So it is also a very fast process of measuring. Okay, this is known as tachyometric surveying. Then there is plane table surveying, where in the field correspondingly you will perform your drawing. That means here in all the other cases you are at first measuring, and in the room you are drawing with the help of the other instrument. But in this plane table surveying, you will take a drawing table, and it will be means paper will be there along with it, and you have to draw simultaneously, perform the field work. For the time being I will say only this part. Ultimately we will discuss those part in details. And then there is theodolite surveying, where mainly what we will do, not only we will measure the horizontal angle between two lines, but also we can measure the vertical angle between two lines also. Suppose this is sorry, suppose this is these two mountains, right? Three mountains say, and suppose this is the horizontal plane, and suppose you are here, and suppose this is your theodolite. So what you can do, take, you can measure the angle between this and your theodolite. How? You will just plot their projection in a plan. So if you plot their projection in a plan, what will happen? This will be A, this will be B, and this will be your theodolite C. So obviously you can measure this angle ACB by just measuring their horizontal angle in a horizontal plane. And also suppose this is D, you can measure this angle also. Suppose this is C, right? You can measure this vertical angle also, ACD. Then what you have to do, you have to draw, you have to plot them in a vertical plane. Then what will happen? In this vertical plane it will be A, and suppose this is your C, and suppose this is your D, another mountain. This is the top of this mountain, this, the D is the top of this mountain. So obviously if you look from this side, this will give you a point, this will give you a point, and the vertical angle will be given by the theodolite. So theodolite not only can measure the horizontal angle, but also can measure the vertical angle. The theodolite which we are having in our laboratory is the manual theodolite. That means you have to measure the distance, measure the angle manually, right? But the advancement of this is also there, like electronic measurements of the angle is also there. Then after that, along with this theodolite, EDM technology is added. That means electronically distance measurements technology is added, where what is happening, you are from here, from a single point, one EDM machine will be there, will give a rays of light, and on the other side one reflector will be there, and from this reflector it will be reflected back, and here not only the rays will go, but also one receiver will be there. So depending on the time of this rays going and again coming back and again it is receiving, there will be some time lag, and that time lag will be multiplied by the speed of this sort of light, because this sort of light is speed of the light is specified because one specific type of light is going through it. So by this you can measure the distance. So theodolite along with the electronically distance measurements is combined, and then the more advanced instrument or total station is actually developed. So right now almost all this chain surveying, traverse surveying, theodolite surveying, tachymetry surveying, plane surveying, all this sort of instrument almost are not in use. So whatever you are studying in the first semester, it is not in use. You are not going to practice these things in the field in a larger amount, because right now total station is in practice. So which you will learn in your surveying 2 classes. But the basis of total station is basically theodolite. So whatever you are learning or not learning from surveying 1, you have to learn theodolite at least. Okay. Hey, again I am saying, what whoever is raising your hand or plotting, giving any question here, try to unmute yourself and ask that question. Otherwise, it will be difficult for me. Okay. So that is the most advanced instrument, which is known as total station. Even not only total station, some more advancement is there in the surveying, like photogrammetric surveying or aerial surveying. Aerial surveying or photogrammetric surveying is basically these two are basically same, not these two only. There is some other advancement is also there. In photogrammetric or aerial surveying, in the aeroplane, it will be equipped with camera, or in the drone, it will be equipped with the camera, and it will take the photograph of the land which we want to survey. So by this process also we can do the surveying, right? So that is basically known as photogrammetric or aerial surveying. These two are basically same. Then there is remote sensing and GIS based surveying or GPS based surveying. Here what you can do with the help of the GIS and remote sensing, by remotely you can access the data and you can do the surveying. So these are the advancement of surveying. Whatever you are learning in the first semester in this surveying one classes, almost all of them are not at presently in use, specifically except leveling and except theodolite, because the basis of theodolite is required for total station surveying, right? In most in our country, in most of the places you will find total station. Right now theodolite is almost obsolete, but you have to learn the theodolite, because to know the working principle of total station, it is very easy if you learn the theodolite. So that's why it is recommended to learn the theodolite before going to the total station. So if you are having any question, you can ask, otherwise we will move to the next slide. কারো কোনো কোশ্চেন থাকলে জিজ্ঞাসা করতে পারো, না হলে আমরা নেক্সট স্লাইডে মুভ করব। কারো কোনো কোশ্চেন আছে এই স্লাইডের ব্যাপারে?
Sir, what is photogrammetric survey?
Photogrammetric and aerial surveying both are same. Basically what you will do, your aeroplane or with the help of the drone, you will set up some camera, you will take the photograph of the area you want to view, and you with the help of those photographs you will analyze those area. So survey based on this sort of photo which you have taken throughout the aerial survey or throughout the drone survey, that is known as photogrammetric survey. Is it clear? Okay, any other question from this part? Otherwise we will move to the next slide. Okay. Okay, so let us move to the next slide. I guess it is clear to everyone, right? So now in survey measurements, the basic two measurements we have to do. One is linear measurements, another one is angular measurements. Linear measurements also can be in two directions. First of all, as I have told you, suppose these are the two mountains, or some lake is there. So in anyhow, when you will do, or you will measure, whatever you have to measure basically the distance in two directions. Basically in a horizontal plane you will just project these things, like in engineering drawing, you know that you have to project in case of isometric view, you have to project all these things from the top, so that you will get the elevation view. If you draw the elevation view, how you will get, this is the point which will be corresponding to this mountain, and it may be spread like this, right? And if you get this point, it will be suppose spread like this. So suppose this is the plan view. Now you have to know the distance between these 2 points. So what you will do, you will measure this horizontal distance. So this is horizontal distance you are measuring. Now if you plot them in the vertical view, so what you will get, you will get this sort of view, right? This sort of view you will get. So obviously this is the this is the vertical distance you will get. This is the vertical distance you will get. So that's how we will measure the vertical distance. So you have to do mainly linear measurements, where you will measure horizontal distance and vertical distance. Also you have to do angular measurements, that is also mainly angular horizontal angle. Suppose from a permanent station point you are placing your theodolite here. As we know, theodolite can measure the angles. So you will place your theodolite and you will measure this angle. You will make this as a 0 degree 0 minute line, and you will move your theodolite to bisect to measure this particular angle. What is this angle? Suppose this is 30 degree, then your horizontal angle will be 30 degree. Similarly, what you can do in the vertical plane, you will make this as 0 then you will move your theodolite in the vertical angle and vertical direction, and you will measure this angle. That means from a point will in the verticals, you will suppose this is your theodolite, you'll measure this angle. So this is your vertical angle. So what you have to do, you have to mainly measure horizontal or vertical distance and horizontal or vertical angles. That's all. Now in horizontal measurements, if you look at the basic units, then obviously we know the basic units like 10 millimeter equals to mainly we will do with the millimeter. If you go in the upward side, then 10 millimeter is basically 1 decameter. Then you will, if you will go to the hectometer, hectometer. Then you will go to the kilometer, right? And if you go into the this side, then what will happen? You will get decimeter, centimeter, millimeter, like this. So you know the basic measurements of the length, which are which already you know. Then the basic units of area, you have to square them, like meter square. So as 1 meter is equals to 10 centimeters, so you square them. 1 meter square equals to 10 square centimeter or 100 centimeters. Sorry, 100 centimeters. Sorry, 100 centimeters. So 1 meter square will be 10 to the power 4 centimeters square, like this. Then the measurements of volume, similarly you can do. So I'm not going in those parts. Basic measurements of angle, here will mostly follow sexagesimal system of angular measurements, where your radian, if it moves by an angle of theta, we know it will make an arc, or it will move an arc length of s, which is equals to arc theta. But if it moves by such an angle that's its length, it has moved in the curve, length is also but mainly we will follow the sexagesimal system, in where one circular arc length is mainly divided in 360, and 1 minutes is divided in 60 part of that, which we know as second. Now it is very important, those measurements and units of measurements already you know, so I have not spent very much time on those, but it is very important to know or to plot the field measurements in a particular drawing. So whatever you are measuring in a field, you have to plot them in drawing. But obviously you are dealing with a large area. If you want to plot them in a drawing, obviously you can't plot them as it is. That means, suppose if you are having a length of 1 kilometer, you have measured in your actual field, you can't plot that 1 kilometer line in a drawing, right? So you have to make a representation possible in the drawing by assuming a fraction of a length. That means what you will do, 1 kilometer length in the field, you will represent them in a drawing by say 1 centimeter. So that means you are basically adopting a scale. Large length you are representing in your drawing by a smaller length. Okay? So that's why we have to adopt certain kind of scale. Now, whenever you will draw something to scale, that means you will measure, you will write down here that every centimeter measured here will represent say 5 kilometer or 1 kilometer, and in the bottom we will write drawn to scale. Drawn to scale means following the scale every measurements has been drawn. So every measurements, if any measurements is not given there in your drawing, ideally you should just give me 1 second. Ideally in your drawing, what you have to do, not only you have to draw your drawing, but also you have to give the dimension. Okay, so you have to do the dimensioning also. Now, even if you forgot to do dimension, if you drawn to scale, what will happen? You can measure the length and you can multiply by the scale factor, and then you can get the total length. What I try to say that in your drawing, suppose you have written, then in our drawing 1 centimeter will be written as 1 kilometer in the actual field. That means, suppose a building you have drawn here, the buildings this side is 2.5 kilometer, this side is 5 kilometer. Then in this drawing, ideally you should do a dimensioning like this is 5 kilometer and this is 2.5 kilometer. Although in the drawing, in the paper, drawing paper, actual scale, actual millimeter measurements which you have drawn here, it is basically 5 centimeter and it is 2.5 centimeter. So basically 5 centimeter is representing 5 kilometer and 2.5 centimeter is representing 2.5 kilometer. Now suppose here is another adjacent building and you have forgot to give dimension. However, you have drawn to scale. Then what can happen? We can measure this distance, and suppose this distance is coming as 3 centimeter. That means in actually there is a building which is having this dimension of 3 kilometer. Is this clear? What is meant by drawing to scale? Is this clear to everyone?
Yes, sir.
Okay. Now, the factor which we are adopting is known as representative fraction. Okay. So the factors which we are adopting is basically known as representative fraction or RF. So what is RF? RF basically, representative fraction, is basically length represented of the ground in the drawing. What is the actual length in the ground which is represented in the drawing? Like here, say 5 kilometer is represented. So 5 kilometer will be in the top. Now, in the bottom, it will be the length of the ground which will be represented by how much length in the drawing. So what is the actual length in the drawing? Actual length in the drawing. So suppose that is 1 centimeter, 5 centimeter. So then it will be 5 centimeters. So 5 kilometer by 5 centimeter is your representative fraction, or we can write 5 kilometer means, sorry, this is I have done wrong. This is actually vice versa. This is actually vice versa. Representative fraction is the length which is in the drawing and the length of the ground or length of the field. So suppose 5 centimeter is actually representing 5 kilometer, then obviously we can write 5 centimeter by 5 kilometer, that is our representative fraction. So or we can write 5 centimeter by 5 kilometer. If you have to convert that to centimeter, what you will do? Will multiply by simply 10 to the power 3, then it will be meter, then 10 to the power 2, it will be millimeter. So 5 into 10 to the power 3 into 10 to the power 2, that much centimeter. So ultimately it will be 1 by 10 to the power 5. So this is your RF or representative fraction. That means 10 to the power 5 units in your field will be represented by 1 units in your drawing. Is that clear? Clear below this our question?
Yes, sir.
Okay. Now, your scale can be of two types. One is numerical scale, another one is graphical scale. Numerical scale is two types also, engineer scale and fraction scale. In engineer scale, we write in this way: 1 centimeter equals to 5 meter. This the left hand side is actually speaking about the drawing side, and right hand side is speaking about the field side. That means in 1 centimeter in the drawing will represent 5 meter of the field. So that's how we will say. and in the fraction scale we will write like this: 1 is to 500. That means in the drawing 1 unit will be actually 500 units of the field. So like this we will plot or we will draw. Now let us convert the engineer scale of a drawing, which is stated 1 centimeter equals to 4 meter. Convert this to fraction scale. If you have understood till this, you can
Sir,
convert
1 is
this.
to 400.
Convert this and tell the answer. Yes?
1 is to 400.
1 is to
400.
yes. How will you get it? Yes, yes, yes.
Yes, both will be in same unit. Then 4 meter is
Yes.
400 centimeter,
Yes.
or we can convert cm to meter. Both units should be
Yes.
same. And
So you have to yes, yes, right. So you have to convert both the things in similar units. So suppose in the fraction scale, what will happen? Fraction scale, it will be simple. 1 centimeter is to basically 1 centimeter is representing basically 4 meter, right? Or we can write 1 centimeter is representing, instead of 4 meter we can write 400 centimeter. So 1 centimeter is to 400 centimeter. This is your fraction scale. That means 1 is to 400, as correctly said by all of you. Is it clear to other students? Please try to, this is a very small example, but the numericals which we will discuss in this class, please try to do those numericals in your exercise book at the time of the class. Otherwise you will not learn. Okay, otherwise you will not follow, you will not follow regular activities, and ultimately at the end of the day you will not learn anything. Okay, you will not learn anything of this subject. So at least try to do those numericals. So similar, in the similar way, so I guess the first problem is clear to all the students. Now in the second question, suppose the fraction scale of a map is given. So suppose in a drawing the scale is written like this: scale is 1 is to 50,000. So convert this to engineer scale. What you have to do? Convert this to
1
engineer
centimeter
scale.
equals to 500.
Huh?
1 centimeter equals to 500.
Yes. So what it is giving? It is giving you 1 is to 5,000, right? A 50,000. So you can write 1 centimeter is to 50,000 centimeter. Now 50,000 centimeter means how? What is the data? 50,000 centimeter means you can write 50 meter. So that means in engineer scale you can write 1 centimeter equals to, sorry, 500 meter, right?
Sir,
I have
500,
written,
yes.
yes, 500 meter. 500 meter, right? So 1 centimeter is representing 500 meter. So that this is engineer scale. Okay. So these are the common example in which type of survey, what is the normal RF or representative fraction we adopt. Like for geographical survey, we normally adopt this sort of representative fraction. For topographical map, normally we adopt this sort of ratio. For location map, like for a building and for other thing, we normally adopt this sort of representative fraction. For forest map, we generally adopt this. For building map, we generally adopt this, like this. So you have to adopt this kind of representative fraction. These are only to give you an idea, but this is not exactly followed, like you have to follow this exactly. No, this is not the case. This is only to give you the idea. Okay. Now, if you have done your measurements with respect to a wrong scale, then how you can correct the length? So suppose if you have used a wrong measuring scale and you have done wrong measurements in the length, so this is wrong measured length. So how the corrected length will be? Corrected length will be representative fraction of the wrong scale by the representative fraction of the correct scale will into the measured length. So that will be your correct length. And corrected area will be this square into measured area, or I can say square of the whole these things, this side. Just squaring both the side, you will get this, right? So that's how you can get. So now let us discuss one problem. Say the distance AB on the ground. So I am field I am drawing like this. Field AB on the ground measured on a plan drawn to a scale of 1 centimeter equals to 50 meter and was found to be 500 meter. Okay. Later it was detected the surveyor wrongly used these things. So what is happening? It is AB is in the field and AB is also drawn in the scale, and suppose AB's length, when the surveyor used a scale of 1 centimeter equals to 50 meter, he found that this length is 500 meter. But actual scale is not 1 centimeter equals to 50 meter, rather 1 centimeter equals to 40 meter. Then what will be the length? So we have to calculate this length. So what is the wrong RF? What is the wrong RF? RF of the wrong scale?
1:40.
RF of wrong scale. RF of wrong scale is
1:4000.
1 to 4,000.
no. Why 1 is to 4,000? I have told you that.
But because it is written, it was later detected at the surveyor, you wrongly used the scale of 1 centimeter.
Sorry, I have just at the time of reading and writing, I have just made the mistake. So this 500 meter he have measured when he have chosen the scale of 1 centimeter equals to 140 meter. But actual scale will be 1 centimeter equals to 50 meter. So if surveyor will choose the actual scale, then what will be the length? You have to measure this. So RF of the wrong scale is basically 1 centimeter equals to 40 meter, or simply 1 by 40 centimeter, right? This one is the correct. Is it clear?
Yes, sir.
Yes,
Right? Okay. Now RF of the correct scale is how much? RF of correct scale?
1 by 5,000.
Right. 1 by 50, 1 centimeter by 50 meter, or 5,000 centimeter. So 1 by 5,000. Now what will be the corrected length? It will be the RF of wrong scale. RF of wrong scale by RF of corrected scale multiplied by the wrong measured length. So what will be the actual data? 1 by 4,000 by 1 by 5,000 into the actual data, which is 500 meter. So that means 5,000 divided by 4,000 into 500 meter. So this 3 digit, if you part,
625.
yes, so it will be 125, it will be 625. So what is happening actually? When you have adopted once, so I guess the problem is clear. Now I am going a little bit explaining this part. I guess the problem is clear to everyone. Okay.
Yes, sir.
So okay, what he is doing, he have chosen a 1 centimeter to 40 meter, and with this measurement he have observed this length is 500 meter. That means actually he have seen that in his scale, in the drawing, he have seen the measurement is actually 12.5 centimeter, and that's why he have multiplied that by 40, this scale for 4,000 here, and he have got 500 meter, because 1 centimeter is 40 meters, so 12.5 centimeter will be 500 meter, and that's why he have got 500 meter. But this scale is wrong, but his measurements is correct, 12.5 centimeter. So that measurements now he will multiply by 50, so we will get 625. Is it clear? So that is the actual case what is happening. Okay, in the drawing when he is measuring with the help of the scale, he is getting this data 12.5, and he have multiplied by this scale factor and he have got 500 meter. He, if he change this scale factor, he can again multiply this 12.5 and he will get 625. Okay, so that's how he is actually calculating the data. Now it is very important to draw the scale in your drawing also, not only to written that 1 centimeter will represent this much, because what happen with time this map may shrink. If this map shrinks, then obviously all the lengths will shrink. So previously which is drawn as 10 centimeter to represent say 10 kilometer, suppose after shrinking it is now representing 9.8 centimeter. So if scale is not drawn, if it is only written 1 centimeter equals to 1 kilometer, what you will do, you will measure this distance and you have found that this is 9.8 centimeter. So obviously you will take this as 9.8 kilometer. So with the help of this map, when you will go to your field, you will claim only 9.8 kilometer. So this will be the problem with the shrinkage of the drawing, and that's why it is very important to draw the scale in your drawing. Okay, to draw a scale in your drawing, so that ultimately we can be sure by measuring this length of the scale also. If we see that this scale length which is drawn 1 centimeter and written that this will represent 1 kilometer, if we measure this 1 centimeter, this will also not be 1 centimeter if the shrinkage is there. So obviously we can calculate the shrinkage factor and we can calculate the changed length, right? So is it clear what is shrinkage factor and why you have to draw the scale in your drawing? Is it clear to everyone?
স্যার এটা একবার এক্সটেন্ড করলে ভালো হয়।
Okay, okay. Suppose in your drawing you have measured the building or the plot of your building. Suppose you are in the field, you are having a plot, you have drawn corresponding to this plot, you have plotted a diagram and you have marked the other points also, or what is the others plot, right? But your plot is primary concern. Suppose in your plot you are having in this side say 10 kilometer and this is 5 kilometer, and abrupt data, I am just giving you an example. Now suppose when you have in the beginning you have done your survey, you have plotted this diagram, so obviously you have chosen a scale. Suppose you have chosen a scale where 1 centimeter will represent 1 kilometer. So then this 10 kilometer obviously will be represented by 10 centimeter in your drawing, right? Is this up to this point it is clear, I guess, right? Now this 5 kilometer also will be represented by 5 centimeter. Is this clear till now? Okay, is this clear, those who are asking the question? Now what will happen if after some days with the help of this plot you have went to your field and you want to just construct a building? So in the beginning what you will do, you will first set up your permanent your major control points or station points, major station points. You will go from the whole to part. So obviously in the field with the help of this drawing you will mark your first end 4 points. Now while doing this you have seen here that due to the time passing of time this drawing has become shrink. You don't know that it has shrinked, and this 10 centimeter is now right now showing 9.5 centimeter. That 5 centimeter is now showing some say 4.75 centimeter. So then, and in the drawing it is written that 1 centimeter will represent 1 kilometer, but no scale is drawn. So from this drawing when you will again mark your permanent stress point in your field, what you will do, you will mark this point, and from this point, suppose if you want to go to the next point, what you will see, you will see here in the drawing you are having 9.5 centimeter measurements, and your scale is 1 centimeter equals to 1 kilometer. That means you are having the idea that this length is 9.5 kilometer, so you will go up to 9.5 kilometer and you will plot this point, right? Are you getting my point? So there is a wrong thing which you will do. So that's why not only in the drawing you have to write the scale, but also you have to draw a line of length 1 centimeter, exactly 1 centimeter, and you have to write this is representing 1 kilometer. So that is known as drawing a scale in your drawing, because it should be there, otherwise we will not be sure of the shrinkage. If it is there, then we can measure the right now its length. Suppose it is not 1 centimeter, suppose it is 9.5 millimeter, or I can say 0.95 centimeter. If this is representing 1 kilometer, then we can be sure, oh, okay, right now it has been shrink, and that's why 9.5 centimeter is actually representing this much amount, because in the when the drawing will shrink, all the lines drawn on this also will shrink, right? So right now you will say that 0.95 is representing this much. That means 9.5 centimeter in our drawing is basically representing 10 kilometer. Then you will go to the 10 kilometer. That's why it is very important to draw a scale on your drawing. Is it clear? Is it clear? आगे जो बोल क्लियर है नहीं? Okay. So that's why you have to draw a scale on your drawing also. Now we'll go about discussing the shrinkage factor. Shrinkage factor is basically the shrunk length by the original length, or shrunk scale by the original scale, or the shrunk representative factor by the original representative factor. So shrunk scale obviously will be the shrinkage factor into the original scale. So correct distance obviously will be measured distance by shrinkage factor. Okay. So now we will go and discuss about an example. Suppose the area of the plan of an old survey plotted to a scale of 15 meters. So the example I am explaining, this is the field. In this field, if you have measured 15 meter, that you have drawn in a drawing, and that 15 meter is basically represented in 1 centimeter. So you have to write 1 centimeter equals to 15 meter. Okay, this is the scale. Now the area, now one area you have drawn here, one area which is earlier there in this field is drawn here. Now suppose we have calculated the area from this drawing, and suppose this is coming as 80.2 centimeter square. However, at the time of drawing is 1 centimeter equals to 15 meter, that is okay. But in actually, as the time has passed, it has been shrunk. It has been shrunk in the way that right now 10 centimeter in this drawing, in the actual drawing, is actually now representing 9.8 centimeter. So when you have measured this 80.2 centimeter square, it is basically measuring with the help of this. Then please find the shrunk scale and the true area of the survey. So how we will do that? So first we will calculate the shrinkage factor. So what will be the shrinkage factor? This will be our step 1, calculating the shrinkage factor. Shrinkage factor, as we know, is shrunk length by original length. Now, what is your original length? 10 centimeter will represent 9.8 centimeter. So obviously your Shrinkage factor will be 0.98. Is that clear up to this part? Is that
Yes,
clear?
sir.
Yes, sir.
Okay. Now, what is your shrunk scale? Shrunk scale, as we know, shrinkage factor into original scale. So shrinkage factor is 0.98 and original scale is how much? 15 meter is represented by 1 centimeter. So multiply just by 15 meter. So it will be 14.7 meter. That means right now 1 centimeter in your drawing is basically represent 14.7 meter. Now what will be the corrected length? Corrected length will be measured length by shrinkage factor. Corrected area will be measured area by shrinkage factor square. So in the similar way, as you have got your shrunk scale, so which is 1 centimeter will represent 14.7 meter, or I can say representative factor is equals to 1 centimeter to 14.7 meter we have got. Sorry, this is wrong. One just wait. 80.2 centimeter square as found by the planimeter. Okay, 80.2 centimeter square as found by the planimeter. Now measured as 80.2 centimeter square found by the planimeter. So what you have to do? You have to measure the corrected area. So please measure the corrected area.
Sir, 83.5068 centimeters.
80
3.5068 centimeters. Or 83.51 centimeters.
83.51 centimeter square. That will be the corrected area. Now you have to yes. So your corrected area 3. Corrected area will be simple measured area by SF or shrinkage factor square. So obviously your area will get 83.51 centimeter square, right? That you are getting now.
Yes,
Hello?
by rounding it off.
Huh?
By rounding it off to the nearest.
No, 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 83.51. Now, the actual area in the field, how much will be? You have to multiply by the simple scale, which you have done. 1 centimeter equals to 15 meters, so 1 centimeter square equals to 225 meters square. So, actual area in the field, although it is not required because they have not asked, but actually in the area in the field will be how much? In place of centimeter square, you can just multiply by 225 meters square. Is that clear? If the area in the field is required to measure, then you will do this. Otherwise, you don't require to do this. Okay? Is it clear?
Yes, sir.
So corrected area is this much and field area. Suppose I am writing field area. So field area will be how much? 83.51 centimeter square. Now instead of 1 centimeter square, we can write 15 meters square because ultimately in the drawing 1 centimeter is representing 15 meter. So ultimately 83.51 multiplied by 225 that much meter square. So calculate what is the actual area in the field.
18,789.77 meters.
Can you tell once again? Can you tell me?
18789.7.
1878.
9.75
Huh?
meters.
So this much will be the actual area in the field. Okay. So if you again have to plot, then this will be the actual area. You can't multiply 80.2 by 15 meters square. You can't do that. Then your area calculation will be wrong. Is it clear to everyone? So what is the importance of shrinkage factor or shrunk scale? So can I move to the next slide? Is it clear to everyone? Okay.
Yes, sir.
Okay. Now we will discuss about three types of scale. One is plane scale. Plane scale is the scale on which you can measure, you can only possible to measure two dimensions. Suppose your dimension is kilometer, 1 centimeter, here you are representing basically 250 meter or 1 kilometer, like this. Suppose 1 centimeter is representing 250 meters. So in a drawing, a 44 centimeter length will represent is basically 1 kilometer. So suppose you have drawn a scale like this, 0, 1, 2, 3, 4, 5, and then you have again classified, you have divided this 0 to 1 length in this side in 10 equal division. Then each one of them will represent 100 meter, as each one of this is 1 kilometer. So 10 division, that means this will represent 100 meter. So like this, only two dimension is possible, either meter and decimeter, or kilometer and hectometer. 100 meter means 1 hectometer. So only two dimension measurements is when it is possible. Then this is only possible with the help of the plane scale. So you can see the zero will be in this side and the increase in this side, and the smallest division will be on the left side. Now suppose you have to measure a particular length, then what you will do?
Sir, why is it written 1 centimeter equals to 250 meters? Then it is written, and you are saying 1 centimeter
uh,
equals to 1
you
kilometer.
just don't have to think this, because ultimately you have prepared this scale. 1 centimeter, the scale will be written, because if you, this is drawn in the drawing paper, if you measure this length in your millimeter or centimeter scale, you will find this is one, this is actually 4 centimeter. From 0 to 1, this is 4 centimeter. That's why I have written here. Okay.
Okay, sir.
Okay. So now suppose if you have to measure this AB length, what you will do? You will go by like this. If you place 0 here, so you can see the length will be more than 4 but less than 5, right? Is it clear to everyone? You are placing 0 here, then it will be more than 4 but less than 5. So it will, the length of the AB in actual field will be more than 4 kilometer but less than 5 kilometer. Is it clear to everyone?
Yes, sir.
Now what we will do, as we are sure that it is more than 4, less than 5, so we will place our 4 to the next end. So we'll place like this, like this. We'll match 4 with this end. Now see, this end is matching on which direction? It is crossing the 0 by 3 smallest division, and each smallest division is basically 1 hectometers, or here I can be sure that it is 3 hectometers. So ultimately the length of this line is 4 kilometer 3 hectometer. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay, so the length of AB is basically 4 kilometer 3 hectometer. So this sort of only two dimension means, if you are measuring actually kilometer, 1/10 of that is possible. That is done, can be done in plane scale. Okay, so I guess this is clear. Now, how this sort of plane scale is drawn in your drawing? So suppose one example is given. Construct a plane scale of 1 centimeter equals to 250 meter, and show 3 kilometer 7 hectometer on that scale. Oh, sorry. Yes. So before drawing these two, what we have to do, our first step, I'm discussing by steps. As you have to draw the scale on your drawing, so what we will do, we will simply know that 250 meter of our field will be represented by 1 centimeter in our drawing. So if you multiply by 4, this will be 1000 meter, which will be represented by 4 centimeter. Or simply 1 kilometer will be represented by 4 centimeter. Now what we will do, we will take 24 centimeter length in our drawing. So our second step will be to draw exact 24 centimeter. The length of this is exactly 24 centimeter. That means ideally it is representing how much kilometer? 6 kilometer. Is it clear? Is it clear to everyone?
Yes, sir.
Now this 24 centimeter length we will divide in 6 equal parts, like 4, 4, 4, 4. Suppose these are the equal 6 parts. Now this point here I will write 0, here I will write 1, here I will write 2, here 3, here 4, here 5. That means if this is all 0, from 0, 1 is at a distance of 4 centimeter. That means basically at a distance of 1 kilometer. So I will write this as 1 kilometer, this as 2 kilometer, this as 3 kilometer, this as 4 kilometer, this as 5 kilometer. Now from this 0 to this is also 1 kilometer, but we will subdivide this into 10 small divisions. So obviously in each one small division will represent 1 hectometer, and it is representing by 10 hectometers. So 1, 2, 3, 4 like this. Here it is 1, 2, 3, 4 like this in the reverse direction up to 10 hectometer. Right? So that's how we will measure, we will give our scale in our drawing. Now suppose with the help of this scale, so this is our scale, how we have drawn that, that is basically represented here. So this is the scale which you have drawn. Is it clear? এইভাবে আমরা স্কেলটাকে ড্রয়িং এ প্লট করব. Is it clear?
Yes, sir.
Okay. Now with the help of this scale, they have in the question they have asked to draw to plot 3 kilometer and 7 hectometer. So I will draw a line so that, sorry, just give me 1 second. So I will just draw a line so that it will start from 3 it will just start from 3, and on the other direction it will move up to which point? You can see up to this point after crossing 5, 6, 7, because then it will represent say 7 hectometer, or from 0 to 3 it is 3 kilometer. So this will be the line's length representing 3 kilometer 7 hectometer. Is it clear? Is it clear to everyone?
Yes.
Okay. So
Yes, sir.
can I move to the next slide?
Yes, sir.
Okay. Okay. Now in the plane scale we are able to draw 2 points or 2 dimensions we can go up to, but it is also possible to go up to 3 dimensions in diagonal scale. If you have attended your first year classes in offline, or already you are then you will be already at by this time you are exposed to this sort of scale, because you are in ED class you have to purchase all this sort of scale, you have to draw your drawing, all these things you have to do. So now in the diagonal scale we can go up to 3 dimensions like kilometer, hectometer, and then decameter, right? In the plane scale we are only able to go kilometer and hectometer. Here you can go up to 3 dimensions. Okay. Now diagonal scale is based on the principle of basically similar triangles, where if you we know that how a similar triangle performs. Say suppose this is the length AB and you have to divide AB in 10 equal lengths. Then what we can do, we can simply plot a perpendicular to AB. Suppose this is BC of any length we can plot BC, a perpendicular to AB of any length we can plot. Now suppose this BC length we are dividing it in 10 equal parts like this, and suppose from these parts and before this part AC is joined. Now suppose from B parallel to AB is drawn like this, like this, like this, like this, like this. Now you know that this 9 9 line or 9 9 dash line is basically represent 9 by 10th part of this. Okay, as this is divided in 10 parts, so this smaller part is also 1/10 of this, because if you go by similar triangle, then 1 1 C and ABC. So AB is basically 10 times of 1C, right? Because you have divided this BC. So sorry, BC is 10 times of 1C, because you have divided BC in 10 equal parts. So obviously 1C will be 1 by 10th part of BC. Similarly, this 1 1 also will be 1/10 of AB. Is that clear? Similarly, 2 2 will be 2 by 10th part of AB. Similarly, 3 by 3 is also 3 by 10 part of AB by the principle of similar triangle. Similarly, 9 by 9 part 9 dash is also 9 by 10th part of AB. So from A, if you have from B, if you have to measure a particular 1/10th distance of AB, what you will do? You will just plot the perpendicular of this, and this distance will be 1/10. So basically, diagonal scale is based on this principle. Is this principle is clear? We will come to the diagonal scale later on. Is this principle is clear? This is basic geometry, right? Which you have learned in your class 10, 11. Is this clear to everyone? Or I will explain again. Is this clear?
Sir, can you explain again?
Okay, okay,
I got offline in between.
okay. So suppose AB is a line, we will draw any length BC perpendicular to AB. Now I can divide BC in 10 equal parts. Say I have divided BC in 10 equal parts. So 9 10 will be equals to 8 9, will be equals to 8 7, will be equals to 7 6, like this. So I have divided in 10 equal parts. Now I have joined AC and I have drawn parallel to AB from this 9 8 7, like this parallel I have drawn. So obviously each line segment like this 1 1 2 2 3 3 4 4, this will represent some part of AB. 1 1, this is the very smallest part, and this will represent 1 by 10th of AB. Why that is happening? Because if you look from this side, this is basically similar triangle. Suppose this is B and this is C and this is A. So obviously BC has been divided in 10 equal parts. So suppose this is 1 point. So 1C is basically 1/10 of BC, right? Or I can write 1C by BC is equals to 1/10 from this equation. Now from this equation also we can write this is 1 1 dash. So 1 1 dashed by 1C, that is perpendicular by base, will be equals to AB by BC, right? Because the similar triangle. Now 1C, sorry, 1 1 dashed by AB, from this equation we can write 1C by BC. 1C by BC already you know, that is 1/10. 1/10. BC by 1C is equals to 1/10. So 1C by BC is 1 by 10th. So obviously 1 dashed also will be 1 by 10th of AB, right? That means this smaller part will be 1/10 of this AB. 2 2 dashed will be 2 by 10th part of AB. 3 3 dashed will be 3 by 10th part of AB. Like this. Is it clear right now? Is it clear? Clear হয়েছে সবার কাছে?
Yes, sir.
Okay.
Yes, sir.
So in the diagonal scale, now what we will do? In the plane scale, if you see, the upper part is not there. Only from 0 to 1 2 3, and from 0 to 10 you can divide it in equal parts. So 0 1 2 3 4 5, like this 10 parts is there. So suppose this is representing meter, so this 0 to 1, this will represent decimeter. Now this 0 to 1, you can divide it further in 10 equal parts, but here doing this is very clumsy, it will be, and you are not able to measure. That's why what has been done, it has been extended to a certain length, like this length. This length is not prefixed, you can extend up to any length, only this needs to be perpendicular. So this principle basically we are applying. Okay, Similarly 10, you are just uh, just you are what you are doing, just extending this line, or you are drawing the same length line and perpendicular to this line. Now what you will do, now very simple, this 10 you will join with 9. Okay, in this, like 0 to 10 plot is there, here also will plot 0 to 10, all the marks you will plot. Now what we will do, this point will join with this point will join with this, like this you have joined. In this way, what you are basically doing, basically you are making this as a triangle. Can you see this 9, and if you take this as a 10 dashed, then 10 dashed, 10 and 9 is basically a similar triangle, and this 9 10 is basically divided in 10 equal parts. Can you guess, this part will be 9 by 10th of this length. Are you getting my point? Is it clear to everyone?
Yes, sir.
Please see, this length will be 9 by 10th of this length, right? This length will be 8 by 10th of this length. This length will be 7 by 10th of this length. Like this you are doing. So that's why it is very easy to measure up to 3 dimensions in diagonal scale. So now suppose if you have to measure this length, what you will do? You will go by this, you will say plot this line, say plot this line. So suppose, obviously it is more than 2, if you can see it is more than 2 and less than 3, so you have to go like 2. From 2 if you go, obviously it is more than 2.6, you can see if you go in the plane scale only. Sorry, please hang a little bit, just wait for 1 minute. So as you can see, it is more than 2. It is more than 2.6. That means it is more than 2 meter and 6 decimeter, because in this end you can see it is crossing 6. But how much we don't know. That's why we have to go in the upward direction. And you have to see, you have to go about this dimension. Because it will not reach this one, because it is in between 2 meters, 6 decimeter and 7 decimeter. So you have to follow this line and you have to see on which point it has matched. So suppose you have going like this, you are going. Suppose you are going like this. Yes. So it is more or less say matching this point. That means the length is 2 meter, 6 decimeter it has already crossed. Now we will go in the upward direction, how much units it has crossed. So obviously it is 2 meter, it has crossed 6 decimeter. Now we will see in the upward direction how much points it has gone. 1, 2, 3, 4, 5, 6. That means this will be represented 1 by 10th of decimeter, that means centimeters. So this length of this line is basically 2 meter, 6 decimeter and 6 centimeter. Is that clear? Is this dimension measurements is clear? এটা কি বোঝা গেল নাকি আরেকবার বলতে হবে? Is it clear?
Yes, sir.
Okay. Can I go to the next slide? Can I go to the next slide? Is it clear, I guess?
স্যার ডেসিমিটারের পর সেন্টিমিটারটা কিভাবে ক্যালকুলেট করলাম?
Okay, you can see, as I have told you that each smallest fraction, as you can see, from 6, suppose 6 is this, right? Whenever you are moving a little bit from 6, you can see from this point, if you draw perpendicular, this will be like this. But from this, whenever you are moving to this point, you are moving by a distance. And what will be that distance? That will be 1/10 of these measurements. This measurements is 1 decimeter, so obviously this will be 1/10 of that decimeter, so obviously it is 1 centimeter. When you will move up to this, you are moving basically 2 dimensions, so it is you are moving basically 2/10 of this dimension, so it is basically 2 centimeter you are moving. Similarly, you are moving to this, then you are moving from this perpendicular to, from this perpendicular to 3 by 10th distance, so you are moving basically 3 centimeter. Like this you are moving, and when you have matched, you have seen that it has matched this point. Okay, this point, that means after 6 again you have to move to sixth point so that it is matching the end to end. So ultimately after crossing 2 meters 6 decimeter, as you have to move further in this direction. This direction means actually basically from the perpendicular you are moving a little bit. Suppose you at 6 dimension you are matching perpendicular perfectly. From 6 if you draw a perpendicular, this will be this much, then only very small part you are moving which is not plotted here, and that will be how much? That will be 6 centimeter. Why 6 centimeter? Because it is matching 6 units here. If it is matching this unit, then it will be 7 centimeter. If it is matching this unit, it is 8 centimeter. If it is matching this unit, it is 9 centimeter, like this. Is it clear?
Yes, sir.
হ্যাঁ বলো বলো, কে কি বলছো?
Yes, sir, I understand.
Okay, okay. Okay. You just look at this diagram, this will be very much clear. Sorry. Anyone who is having problem, just look at this diagram. Just look at this diagram. This part. From 0, this is the perpendicular, you are moving a very small distance here. But that will be 1/10 of this distance. You are moving a little bit more distance here. That will be 2/10 of this one. So this is 1 decimeter, so it is 1/10 of this means 1 centimeter, 2/10 of this means 2 centimeter, 3/10 of this that means 3 centimeter, 4/10 of this that means 4 centimeter, 5/10 of this that means 5 centimeter, like this. Similar way from the others also, if you draw the perpendicular, this much distance you are moving. That's why it is centimeter, it is written here. Okay, so that is basically diagonal length. Now we'll go towards vernier scale. This is very important, corresponding to theodolite. In the next day, we will go to the discussion of our module theodolite, which I will discuss and which you have to understand because of the total station, which we will discuss in the second semester, right? Which you have to know. Before that, you have to know the theodolite part. So in the vernier scale, already in the physics laboratory in your class 11, 12 also you have performed vernier scale, and we know that in the vernier scale what happens, basically it is the mechanical magnification, right? Like with the help of the lens we can magnify. Similarly, it is the mechanical magnification. That's all. What is happening there? One main scale will be there and one vernier scale will be there, and say 10 vernier scale is equals to 9 main scale reading. That means suppose in the main scale, smallest reading is 1 millimeter here, this is representing 1 centimeter, so smallest reading is 1 millimeter. Now if you go from 0 to 1, that means centimeter, small 9 division is there. Suppose 9 division, up to 9 division, it is representing a length of 9 millimeter. And in vernier scale, suppose this is 10 division, that means one vernier division is basically representing 0.9 millimeter. Now, what is the least count of any vernier scale? Well, vernier and main scale will be there. That will be simple. The minimum division of a main scale minus minimum division of a vernier scale. So minimum division of a main scale is how much? 1 millimeter. And minimum division of a vernier scale is how much? 0.9 millimeter. So ultimately, least count of this instrument is 0.1 millimeter. So you can measure up to a fine degree of 0.1 millimeter with the help of vernier scale. Okay, let us go to this. You can see this is 0, this is 9 in the main scale, and 9 is matching with the vernier scale 10. Hence, here the least count will be 0.1. As in the main scale the division is 1, and the vernier scale division will be 9 by 10. So 0.9. So least count will be 1 minus 0.9. So 0.1. Like this. Now you can see the vernier 0 that will act as an index. Index means pointer that will denote the data in which has been already crossed. And so suppose it is in between main scales 3 and 4. So already 3 millimeter crossed, but 4 millimeter is not reached. So that is why it is called index or pointing finger. You can think of like this as a pointing finger. This will be the vernier 0. Now we will discuss about the direct vernier, which is mainly common and which will mainly use. If the vernier which extend or increase in the same direction in which the graduation of the main scale is also increasing, so if this is increasing in this direction, vernier is also increasing in this direction, this will be called direct vernier. One other type of vernier is there where main scale is increasing this direction and vernier scale is increasing on this direction. That means 0, 1, 2 like this, and here 0, 1, 2 like this. This is called retrograde vernier. This is called direct vernier. Okay. So here you can see n division of main scale is equal to the n plus 1 division of vernier scale. So then what will be your least count? As we know, if P the value of the smallest division of main scale, say P is here 1 millimeter, P is the smallest division, then n division or 9 millimeter, n division or 9 millimeter means NP length is actually represented by the 10th division of vernier scale. That means n plus 1 division of vernier scale. Now in vernier, suppose 1 division is small v. From this to this is small v. Then small v is n by n plus 1 into p. Then what will be our least count? It will be simple p minus v. So p minus n by n plus 1 into p, or p if you take common 1 minus n by n plus 1, or simply 1 by n plus 1 into p. So simply the least count or the smallest division in the smallest division in the main scale divided by the number of division in the vernier scale. Number of division in the vernier scale. So 10. So that's how it will be decided. What will be the least count? Is it clear to up to this one? Up to this portion, is it clear? Vernier scale?
Yes, sir.
Okay. So suppose this is a vernier scale. This is a vernier scale. If you match this 0 to this 0, you will see this 9 length is matched to 10th of this vernier. So obviously then what will be the least count of the instrument? It will be the minimum division of this one, which is 1 millimeter, right? 1 millimeter, because these are the centimeter. So obviously it is 1 millimeter. 1 millimeter divided in 10 parts, because we have seen that p by n plus 1, n is the division, n plus 1 is the division in the verniers. So that means 10 exactly. So 1 millimeter divided by 10, that means 0.1 millimeter is the least count. Okay. Now how we will do? Check this 0 is an index or indicator. This 0 is indicating that in the main scale it has crossed this point, but it has not reached this point. That means 2 centimeter, 1 millimeter it has already crossed, or I can say 21 millimeter it has already crossed, because this is 20 millimeter, this is 30 millimeter. So this is 21 millimeter, this is 22 millimeter. So the reading is in between 21 to 22. Is it clear? Is it in between 21 to 2? Because 0 is the index or the pointing finger. Is this clear? Up to this, is it clear to everyone? Please understand this part very clearly, because before discussing theodolite, you have to know this part. Is this clear?
Could you repeat that?
Yes, I can, but you have to understand this part. Your vernier scale is movable like this, right? Now, whatever I am saying, Least count part is clear to everyone, right? Least count is basically what we have got, the minimum division in a main scale divided by the total number of division in a vernier scale. Like here, vernier division is 10, so 10 is basically representing n plus 1. N is here 9 because 9 of primary scale is representing 10 of vernier scale. That's why n plus 1 is 10. And smallest division is here is 1. That means least count in this vernier scale in this scale will be simple 1 millimeter by 10. That will be the least count, like 0.1 millimeter. Is this clear? Least count part is clear to everyone or not? Okay. Now here also in the similar way the least count is 0.1 millimeter because you can see these are centimeters. 0 centimeter, 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter. But in the main scale also some smallest division is there. Like this one, you can see such 10 division is there. So each one is of them it will represent 1 millimeter, 2 millimeter, 3, 4, 5, 6, 7, 8, 9, 10, right? So these are also millimeter it is representing, or I can say these are representing 10, 20, 30, 40, 50 millimeter, right? Now, zero of the vernier is basically the index, or it will denote how much you have crossed. So how much you have crossed? If you see the zero of this one, how much if you have crossed? Please tell me from this scale. How much you have crossed in the main scale? How much you have crossed in the main scale? Please tell me.
21 mm.
21 you have crossed, but 22 you have not crossed. So your data will be within 21 millimeter to 22 millimeter. Is that clear?
Yes, sir.
Okay. Now forget this part. So it will be 21 plus something. We don't know. 21 plus something. We don't know. Now what we will do? We will see this line and we will check at which line in the vernier it is exactly matching with the main scale line. You can see this line is not matching. They are having some difference. They are having some difference. This line is perfectly matching. Can you see? This line is perfectly matching. বলো কি বলছো?
No, no, sir, ঠিক আছে, sir.
Okay. Can you see which line is perfectly matching? Can you see this line is perfectly matching? Right?
Yes, sir.
That you have to determine. And how much in the verniers you have crossed from 0. This is 1 division, 2 division, 3 division. Is that clear? Is that clear?
Yes, sir. Yes.
Now, then what will be your reading? It will be 21 plus how much division you are crossing, where your line is exactly matching with the main scale. That is 3 into the least count of the vernier. That is 0.1 millimeter here. So obviously your data will be 21.3 millimeter. Is that clear? This dimension taking, is that clear?
Yes, sir.
Okay. So in a similar way, you can measure the data here. Here what is happening? Here basically you can see in the vernier 20 division is there. And in the main scale it is 1 millimeter. So here least count will be how much? It will be 1 by 20. Right? Is that clear?
Yes, sir.
Okay. Now you can see here 0 have crossed which line? It has crossed 2. That means 20 millimeter it has crossed, but it has not reached 21. So what is the index from here you are getting? Obviously your data is within 20 to 21. Is that clear?
Yes, sir.
So your reading will be how much? From the main scale you are getting 20 millimeter plus at which line in the vernier it is exactly matching with the main scale.
The third.
Third one. So three division. Now what is the least count here? It is 1 by 20 or 0.05 also we can write 0.05. That means 20 plus 0.15. So 20.15. So this will be our data. Is it clear? So this will be our data. হ্যাঁ বলো কিছু কোশ্চেন করলে নাকি ইয়েস স্যার বললাম আমি বুঝতে পারলাম না you can practice this with this one also. I am not going to discuss this part. Now let us go and discuss this part. If this, if that your linear scale is again can be done in the angular measurements also. Suppose in the main scale, in the angular measurements, you are having smallest division as this one. So this is 68 degree and this is 67 degree. So what is the smallest division? This is not the smallest division. In between them, if suppose two smallest division is there, so what is the smallest division in the main scale? 1 degree is further divided in three parts. So what is one small part in the main scale is denoting? 20 minutes, right? 1 degree is divided in three parts, so it is denoting basically 20 minutes. Now, suppose in the vernier scale, the 60 division of vernier scale is matching with the 59 division in the main scale, then what will be the least count of this scale? It will be similar, 20 minutes by 60. So it will be how much? 20 seconds, right? Is that clear?
Yes.
Is that clear to everyone? Please understand. It is very much important. Is this clear? If I have to repeat, I will repeat. Can you confirm whether it is clear or not?
Yes.
So it is least count is 20 second. So now if you want to measure here, if you see this diagram, this is the zero or the index. Can you tell me this is, you can see that this is increasing in the same way, 0, 5, 10, 15, 20. This is also 0, 10, 15, 20, 25, 30, 30. So in the direct, this is the direct vernier. So you can see 0 has crossed 10 degree, but it has not crossed 11 degrees. So it will be within 10 to 11 degree. Is it clear?
So 10 degree, 20 minutes.
Yes, it has crossed 10 degree 20 minutes. Exactly, 10 degree 20 minutes. We have got the reading from main scale. Now we will see at which distance it has exactly matched with this main scale line. Okay, we have to see at exactly which length it has matched with this main line. Okay,
And this one?
this one, this one
Yes,
you
sir.
are
For
telling.
the sir, 15, sir.
This will
The
be the
one you
15th
got.
line, right? No, if you, this diagram is not that much clear, maybe this is this one. For example, let us take this one. Okay? For example, this diagram is not that much clear now. This is hazy it is looking. Suppose this is at where it is perfectly it is straight line, right? Then this will be how much position? 3, 3, 6, 3, 9, 3, 12, right? So then 12 line into the list count, that is 20 seconds. So 240 seconds, or basically how much minute from here you are getting? 4 minute. So that means your actual data will be 20 degree 24, 10 degree 24 minutes. Is it clear to everyone? Okay. So that's how vernier scale will be measured. What is the time? Do you have a class after that? This after this class? Or I can extend for
Yes,
5 minutes at
only
least.
the A section have classes.
Okay. Then we are stopping here. This the few slides is left for this module one. That is 3 or 4 slides. This will not take more than 5 minutes because this already we have discussed. So in the next day, after discussing this 5 minutes, we will go and start discussing our problem with related to theodolite. Vernier, up to this, please study. I will send you this PPT today. You have to study this part. If you are having any problem with the vernier, please let me know on the next day, because before going to discuss the theodolite part, you have to understand the vernier part. So just wait for 1 minute. I'm just sending you the Google form for attendance. Okay.